Welcome to the simulation. In this simulation, we will learn about the tire change procedure with RIST. In order to help technicians remember the key components of clamping force, TIA created the acronym RIST. R is for remove debris from mating surfaces. I is for inspect the components. S stands for snug the lug nuts in a star pattern. And T stands for torque the lug nuts to specification. Let's start with R for remove debris from mating surfaces. Without a doubt, the most important mating surface on any vehicle is the area between the back of the wheel and the face of the hub. To remove any dirt, surface rust or corrosion, grab the wire brush and collide it with the mating surface. To clean the grease, grab the spray brake clean, point it at the shop rag and use it to apply the cleaning agent to the shop rag. Good. Now clean the mounting surface by grabbing the shop rag with the clean agent applied and collide it with the mounting surface. Special attention should be paid to the center hole of the wheel where it will contact the center ring of the hub. It's also important to clean the outermost edge of the mating surface on the wheel as well as the inside of the wheel so debris cannot fall between the mating surfaces during installation. On this vehicle, there is a noticeable difference after the back of each wheel has been cleaned because you took the time to use a wire brush to remove all of the corrosion from the mating surfaces. Left alone, this condition would have little effect on the torque at installation but a major effect on the clamping force after the joint settles. Finally, the mating surface where the lug nuts meet the bolt holes in the wheel must also be free of any foreign material. The next area that must be cleaned with a wire brush is the mating surface of the rotor or drum. A small wire brush is the best tool for making sure the critical area between the center ring and the center hole of the wheel is free of any foreign material or buildup. To clean the mating surface of the rotor, grab the small wire brush and collide it with the highlighted critical area. If corrosion is trapped in that area, it's only a matter of time before it starts to work itself free as the joint settles, which ultimately results in a loose wheel. It's not the easiest area to clean, but technicians must remember that failing to remove foreign material from any mating surface will have a negative effect on clamping force. The rotors and drums from the previous example show the same noticeable differences after they were cleaned. And like the companion wheels, the clamping force would ultimately be reduced even if the torque was correct. Finally, technicians should remove any lubricants from the rotor or drum like grease or anti-corrosion compound with brake cleaner and a shop towel. To remove the lubricants from the rotor, grab the brake cleaner and press the pointer to spray the cleaning agent on the shop towel. Great. Now grab the shop towel and collide the shop towel with the rotor to clean it. The next step of the RIST procedure is I for inspect. The mating surface of the wheel must be inspected for any cracks or other damage between the bolt holes or between the center hole and the bolt holes. It's also important to inspect the bolt holes on the front side of the wheel to ensure the chamfers are not severely worn and the holes are not oblong. If the bolt holes are obviously damaged or severely worn, the wheel must be removed from service. The mating surface of the rotor or drum must also be inspected for any cracks or damage. To check the hub for any cracks and damage, touch the hub once. Since the studs play a critical role in the process of creating clamping force, they should be checked for any evidence of worn, damaged or striped threads. To check the studs for any evidence of damage, touch the studs once. Remember, if the threads on the stud are in poor condition, the correct torque will result in less clamping force when compared to studs in good condition. The same can be said for the lug nuts or wheel bolts. Normal wear and tear from regular tire rotation and replacement will gradually take its toll on the threads. If the threads are severely worn, the best practice is to replace the fasteners because the correct torque will once again result in lower clamping force values. Finally, the hex surface on the outside of the nut should also be inspected for any damage that could make installation of future removal more difficult. To inspect the hex nut, grab the hex nut and observe for any damage. Components have passed inspection, it's time for the third step of the RIST procedure, which is S for snug the lug nuts in a star pattern. Next, position the assembly on the hub. Good. Now to hand thread each of the lug nuts or wheel bolts. Place a lug nut in each of the highlighted spheres on the wheel to make sure they are not cross-threaded. Some technicians will seat the wheel by hand and then hand tighten the lug nuts until the assembly is firmly seated on the hub. It's also acceptable to seat the wheel by hand, then use an impact wrench set on the lowest setting to tighten the fasteners in a star pattern until they contact the wheel and seat the assembly. To tighten the fasteners in a star pattern, grab the impact wrench and collide with the fasteners while using the impact wrench. Each location will highlight, and when it has been sufficiently tightened, the next location in the sequence will highlight. Repeat this process until all fasteners have been tightened. Well done. The wheel is now set with the assembly. Since the key is to make sure the wheel is evenly seated on the hub center ring and the studs, technicians that use an impact wrench should stop applying force as soon as resistance is detected. When done correctly, it may take several star patterns before the assembly is completely seated. Technicians should never use the one and done method for seating or installing tire and wheel assemblies. Once the assembly is seated, grab the impact wrench and collide with the lug nuts to snug the lug nuts in a star pattern beginning at the 12 o'clock position to approximately 50 pounds. This particular impact wrench is regulated to deliver limited force when tightening fasteners. Once again, if none of the fasteners move in a tightening direction when the wrench is set for the torque that was used to tighten the lug nuts, then the clamping force and bolt tension has been retained. If some of the lug nuts show slight movement, then the customer should be advised to have the fasteners checked again after another 5 to 50 miles. If any of the lug nuts show significant movement during the torque check, then the assembly should be removed from the vehicle so all of the components can be inspected. Significant movement may indicate the studs had reached their yield point during a previous installation and are no longer capable of maintaining the necessary clamping force at the recommended torque. Since clamping force is the key to wheel retention, technicians must take steps to ensure that all of the components are in the proper condition for the recommended torque to secure the assemblies to the vehicle. Experts agree that by following the RIST procedure during every installation, the chances of a loose wheel or wheel-off accident will be reduced.